I would like to show you how I'm going to use the Oracle CrystalBall add-on onto Microsoft Excel. You can download the trial version for Oracle CrystalBall from Oracle website, and here I have already installed the macro. I will just run this and it will open Microsoft Excel and attach the macro, which is the CrystalBall macro, somewhere up here in the menu, as you can see here. And welcome to Oracle CrystalBall, and my primary application I will just put as general. There will be a 15 days trial period for you to use this CrystalBall. Just try and use CrystalBall, and I want to call up a file which I already had created the minimum, most likely, and maximum columns. Now this will be project activity costings. Project activity costings, these are the activities, and these are the minimum, most likely, and the pessimistic costing for each of the activity. And of course you can see that the range from the optimistic to the pessimistic is actually shown in this column. I have managed to use the PERT equation to determine the PERT activity cost, which is F4 pessimistic plus 4 times of most likely, the middle one here, and D4 is actually the optimistic, or the minimum value here. So all of this I have been able to copy the formula, and I have gotten $11,595, and I have went to determine the standard deviation. The project standard deviation is actually calculated by first determining the standard deviation of each activity, which is the pessimistic F4 minus the optimistic, and the whole thing divided by 6. From the SD, standard deviation of each activity, we have to find the variance. The variance is basically the square of the SD of each activity, and I have produced it accordingly here. Now for us to calculate the project expected project standard deviation, I have to total up the total variances of all the activities cost, and that comes up to be 318, as you can see here, 318,402, and it's represented here. We have to make a square root of this total variance to obtain the project standard deviation, so that we have it at $564.3. So therefore our PERT total, which is right in the middle, and pessimistic. Now if you look at my formula for the pessimistic, it is the most likely, which is the PERT total here, the one in the middle, plus I'm using 3 standard deviation away, or rather 3 sigma, and that will be L4, which is 564 multiplied by 3. So this is on the upper range, and this will be the lower range, which is actually the most likely minus the 3 standard deviation, or the 3 sigma, L4 as well. So I have 9902, 11595, and 13284, 87, sorry. And I will save this file, and I'm going to run I want to create a column specifically for the simulation. I will just call it as CrystalBall, so that I'll know that this will be a dedicated column for me to allow CrystalBall to run the simulation. And let me just make this as bold. And what I'm going to do is, in the CrystalBall, I will need to define this section as the simulated output for the random numbers that will be generated for each activity. So for me to do so, I need to go to the CrystalBall menu to make sure I'm selecting that. And since I already highlighted this column, this is a cell, I'll go to the define assumption, and I'm going to use the PERT, otherwise known as the beta distribution. So beta and PERT, they're the same. and I would need to at the name, which is the activity name, it won't be ball, but I would have to click on this to select the field or the cell that contains the name of the activity. In this case, I'm going to use physical site inspection, which is C4. That's okay. And the minimum, again, select it, the minimum for physical site, which is this. Press OK. Over here, I will have to press the most likely, and lastly, over at this end here will be the pessimistic or the maximum value for the cost of a physical site. And I press enter, and you will see that the name that I have actually defined, the name, which is activity name, the minimum, the most likely, and the maximum being keyed in here. So you can see the skewness, it's all to the left hand side. And I'll press OK. And you'll notice there's a color coded in green to indicate that the definition for the Monte Carlo has already been done. So what I'm going to do is I would need to copy this and extend it over to the other fields, the other cells, right, accordingly. But I'll make sure I need to use CrystalBall. I can't go back to the normal home and do a copy. It doesn't work it doesn't work this way. Right? I can't just copy like this. It functions, yes, for a conventional Excel, but because I'm using CrystalBall with all the data and parameters already being keyed in, we have to use a copy from within CrystalBall menu, which is this one here. And you can see that there's the pull-up box here. It says that copy the CrystalBall data into the clipboard. Yes. And I'm going to copy for the rest of the other rows of the activities, and I make sure I want to use the paste called CrystalBall data paste, and I will have this. Now moving on, I would need to make sure that I also define the output from the CrystalBall calculation. So I think I'm going to want to use this cell to tell that the total of this, the summation of this. So I would put in a sum of out of this, close the bracket, and enter. So that's the sum, and I need to let CrystalBall say that we're going to forecast to this point. Basically, everything converges from the simulation, converges to this point to find the total the total project simulated value to be pointed at this target. So I'm going to define the forecast and to inform that this cell, just to make sure that I'm choosing that, is this cell. Just click on the cell for reference, so everything's referenced over here. So just press OK, and I don't have to do anything else. I don't have to define the units, just leave it as it is. Just press OK, and you'll see that it turns into cyan. And make sure I would like to save the file. Now let's run the simulation. Here I have put in 20,000 cycles. In other words, there'll be 20,000 sets of random numbers that are generated between the minimum and maximum, and it must be, of course, reference to each of these activities within that ranges. So be 20,000 cycles of different random numbers being taken out and to find the project cost. And you will expect 20,000 project cost values that we put into a property distribution curve or a histogram. So let's run this step. It's running very fast. It's using Excel to be the engine that does all the calculation, and the CrystalBall which is added in the respective parameters that helps in the simulation. And of course the trials have been completed, 20,000. the more trials you have, the more refined will be the answer. That's the tips for that. Now here, this will be what the forecasted, which is this value here. Of course, everything goes back to 0, and you will see that it ranges from about 10,000 to around 13,200 something. Now, since we are using 3 sigma, and if you can remember, 3 sigma or 3 standard deviation actually means 99.73% of certainty. So if I were to key this in and enter this, you see, oh, okay, that's already the number here, 9811, and that's 13,284. So pretty good. If you were to compare this with the PERT equation, or PERT calculation, it's close for the pessimistic on the side here, and it's a little bit far for the optimistic, because optimistic here is showing 9,811, and that's about here. But what's the one in the middle, right? This is what is actually the gist of it. What we're trying to find using a PERT is to find the PERT value. So let's have a look at the view, the statistics of the simulation, and you'll see that the mean here is almost 11,600. So yeah, 11,599, and this is what they have, 11,595, and there's only a $4 difference, which is pretty good. You know, if you were to use a triangular distribution to do this calculation, you will see that it's way off. And the PERT, in a way, has demonstrated its worth, that it is very close to a real-world event being conducted in a laboratory environment using the Monte Carlo simulation, using this CrystalBall, as you can see here. Now, the next thing we would like to see is, let's open up this frequency table. You can actually slide. You can actually slide the sliders, and if there is a someone comes to you and asks, what is the chance of this project able to be completed in between, let's say, 11,000. Let me just go on the left side. You can see the left slider here, left side here, about 11,000, which is close. Or we'll just key in 11,000. We can just do that, 11,000, enter, and between 11,000 to, let's say, 13,000. And immediately you can read this is the area under the curve, which is demonstrated by covered by the blue shades. That will be 82.86% confidence that the project would end up to be costing anything between 11,000 to 13,000. Now, if there's a question saying that, okay, let me just put negative infinity, INF for infinity, which is all the way to the left side, you can see that. And let's suppose it says that, what's the chance of this project coming in 13,000 or lesser? That will be 99, so it's a very high confidence. Or what about coming in less than 10,000 instead? So if you're coming in less than 10,000, it's like 0.3, so it's very unlikely. Perhaps it would be better if it's just like 11,000. Then you will see that, okay, if it comes, this cost comes in less than 11,000 or less, there will be about 16.5% confidence that we will achieve it. So you can see by using this Monte Carlo, which the PERT cannot provide you information as the possibility or the probability of you finishing the project between one value to another value. Well, the Monte Carlo can provide you that information, which the PERT couldn't. Now let's take a look at another graph which is actually called the tornado diagram, otherwise known as the sensitivity graph or the sensitivity analysis. So let's take a look at the sensitivity chart, and it's actually at the forecast here, right? And you'll see this is sensitivity. That's a 51%. Wow, that's a bit. It means that this is a what called a very critical. This activity will influence the project cost outcome the most. The longer the bar is actually, in a way, it's actually a Pareto chart, or also known as the tornado diagram in the realm of simulation. So I can choose a another viewpoint. I can use ranking in terms of ranking. So the bigger the bar or the higher is the number, the more influential that this particular activity influences the outcome of the project cost the most, ranked from high to low. And what's so special about reporting on safety? Being such a high one, such a influential one, followed by obtain access permit. If I were to bring your attention to the Excel spreadsheet, sorry, you realize that the range reporting on the safety, the range is very wide, and it of course corresponds that there's a wide range of uncertainty between 500 to 100 and 2800, as opposed to a narrower range between 250 to 800. So you will see that the site readiness is actually the least influential to the project outcome. You can see that here. And of course the second one is the access permit. You can see that it's after this access permit, it's this one here. And so you don't really need a tornado diagram or the sensitivity analysis for you to determine which is more influential to the project cost, because by reading here, the range itself is indicative. The bigger the range is, the wider and more influential, because it can swing from anything between 500 to 2,800, and that's a very wide swing of uncertainty. Our objective is actually to talk to the people who's doing this reporting on safety, to narrow their ranges, basically to bring it, like for example 500, maybe 1,005 to 2,005, or maybe 500, if you can 1,000, then 1,500. That's so much better. As long as the range is reduced, it's what we are trying to achieve. So that's Monte Carlo for you using CrystalBall, and you have this set of information that's available to you to do a very good analysis. And we can actually put this back to positive infinity, and you will see that the entire 100%.